Hello everyone, welcome back. I am Harshan. Today we are going to discuss about H-plane T junction. Let's start the video. First of all, what is a H-plane T junction? In the image you can see that's the structure of H-plane T junction, and it is made up of a conductive material and or a metal for a good signal conductivity. And H-plane is a type of junction of a waveguide junction used in microwave engineering. Okay, and it is commonly used to splitting or combining a microwave signal in a waveguide system. And H-plane junction have main waveguide that is connected to a two branches waveguides at the 90-degree angle, and it dimension of the waveguides are carefully designed so that to ensure the signal splitting is and combining is done in efficient way. Let's derive an H-plane T junction. We are considered the HR T junction, and port 3 is an HR, and port 2 and 1 and 2 are collinear, and they have 90-degree phase shift. So, okay, and we are considering a S matrix for a 3 T junction that can be written as like this: S11, S12, S13, S21, S22, S23, S31, S32, S33. Now look at the diagram. If H arm is perfectly matched, so we can write it as S33 is equal to 0 and considered as a equation 1. And now port 1 and port 2 are collinear arms. So we can write it as S31 is equal to S32. So that is equation 2. And we know that by the symmetric property, Sij is equal to Sji. By using this, we can write it as S12 is equal to S21, and S31 is equal to S13 is equal to S31, and similarly we can write it as so S13 we know that it is equal to S32, so that we are written here, and by using symmetric property S32 can be written as S23 from equation 2. That's what here written. So now we considered the S matrix previously, right? So we can write and modify that S matrix as per our requirement, that is S11, S12, S13. S21 is replaced by S13 because it is equal here, and S22 is same, and S23 is replaced by S13. It is here, it is equal to S13. So similarly S13 is replaced by 31 is replaced by 13, and 32 is replaced by 13, so it is equal here. So it is 0 S33 because of perfectly matched. So you got a new modified S matrix. And now as identity property we know that S into S star is equal to I. By using this property, the modified S matrix we are written here, that is S, and S star also written here, and this is the identity matrix of 3 cross 3 order. Now we are performing row into column operation. Watch carefully that we are multiplying R3, the row 3 of the first matrix, with the column 3 of the second matrix. So we get here S13 whole square plus S13 whole square is equal to 1. So by solving we get S13 is equal to 1 by root 2. Okay. Similarly, row 1 and column 1 is multiplied. Row 1 and column 1, that is R1 C1. So R S11 square plus S21 square plus S31 square is equal to 1. So we know the value of S13. Previously we have solved that. We means here it is, here itself S13 we know that we substituted here. After substituting S13 value, you can see that we are solving. We got some equation, we marked it as a something one, and now we are similarly performing R2 C2. We get the another equation, that is I marked as 2. Now equate 1 and 2 now, because the RHS is equal, right? So we are equating the LHS. So we got cancel of these two terms, and s11 is s11 square is equal to s22 square. So square square get cancelled, and s11 is equal to s12. We got this one, mark it as in the block, we use it in further. And s13 sr1c3, that means row 1 column 3 multiplication will be done. So similarly we done here. So we here 0, because why? Because the matrix there we are 1 is to 1, the identity matrix what we have considered it is 0 0 and 0 1 0 0 0 1. So when we are multiplying row 1 with column 3, means row 1 with column 3, you can see we are getting 0 as well in this row 1 column 3. If you multiply, we'll get 0. Because of that we return 0. So after the simplifying this, we got this one, s11 is equal to minus s12, or s12 is equal to minus s11. This we marked in the block. Now equation 1 becomes s11 plus, we are replacing the value here, just we marked as equation and in the before, right? We are marking, we are using, we substitute in the value, that's it. And we are, by solving, we got s11 value that is equal to s22. Because why? Because s22 previously we have marked the symmetry property, identity property, all those equations are be compared, and try to match which is equal to the s11 and s22. By using that, we are written s22, and s12 is value is minus 1 by 2. So finally we got all the values, and s11 s12 s13 s22 s2, all these modified matrix s matrix values. So we are just writing those values, minus 1 by 2, minus 1 by all those things, and we got a final S matrix, that is 1 by 2 and minus 1 by 2 and 1 by root 2, 1 by root 2, like that, and minus 1 by 2 and 1 by 2 and 1 by root 2 and 1 by root 2, 1 by root 2, and 0. This is the final S matrix for the H plane T junction. After deriving, we got a S matrix for the H plane T junction. Now H plane S matrix in the form of, so this is the equation we are considering. B is equal to S into A. S is the S matrix of the H plane T junction. So the value is written here, and we are multiplying those, equating those values, and we got these three equations. That's it. This is the final equation for the H plane T junction. Thank you for watching.